Okay, part 4, special factor patterns. So it's nice when you have shortcuts, when you have ways that you can do this a little bit faster. One of the most common ones is called a difference of two squares. Difference means minus, subtraction. Now two squares, that means perfect squares. Perfect squares. And here's what the pattern is. It's a squared minus b squared equals a plus b times a minus b. Notice that a squared is perfect. That's a times a. B squared is perfect. It's b times b. And notice that we are subtracting them. It is a difference. And so the pattern is you can immediately write the answer a plus b times a minus b. The example I'll give you, if we had, for multiplication, x plus 5 times x minus 5. If you double distribute, you would get x times x. X times negative 5 is minus 5x. But then you would distribute here, you would get plus 5x. Oh, kind of running out of space. 5 times negative 5 is minus 25. Now, we combine the like terms in the middle, but what's negative 5x plus 5x? When you add opposites, you get 0. And what you end up with is x squared minus 25. So notice the middle term got canceled. Well, x squared is x times x. I'll write it like this. 25 is 5 times 5. That's a perfect square. And we're subtracting them. So what we're saying is that if you see this, you can go back to that immediately. You do not need to do a times c, what adds up, what multiplies to ac and what adds up to 0. You can immediately factor this into your two binomials. Okay, so x squared minus 81. Well, x squared is x times x. 81 is perfect. It's 9 times 9. And we're subtracting it. X plus 9 times x minus 9. That's it. Again, you can always check, multiply it out, and see that this is what you'll end up getting. X squared minus 16. X squared is perfect. 16 is perfect. 4 times 4. It's a difference of two squares. Answer is x plus 4 times x minus 4. See, this is fast. X squared minus 100. X times x. 100, 10 times 10. You don't even need to write this. You can immediately just go x plus 10 times x minus 10. If we did it the old way, if you wanted to, x squared plus 0x minus 100, you're thinking what multiplies to negative 100 and adds up to the middle, which is 0. And what you would figure out, okay, it's 10 and negative 10, and there's my answer right there. Okay, so you don't need to go through this process for a difference of two squares. Even if the lead coefficient is not a 1, this is going to work, as long as it's perfect squares. 9x squared, 3x times 3x. What's the square root of 121? It's 11. The answer is 3x plus 11 times 3x minus 11. What's the square root of 144x squared? 12x. What's the square root of 49y squared? Oh, we have two variables. Whoops, 7y times 7y. Well, 12x plus 7y times 12x minus 7y. Even something like this. Now, what you'd want to do here is probably take a calculator and is 1296 a perfect square? Yes, it is. It's 36. So that is 36x. How about the square root of 625y squared? Well, that just happens to be 25y. So plus 25y minus 25y. It has to be plus and minus. It cannot be positive, positive, because that would multiply to a positive number. It cannot be negative, negative, because that would multiply to a positive number. So it's a difference of two squares. One factor has plus and one has minus every time. Now I threw one problem in here to try to fool you. You will be tempted to say, okay, that's x times x, that's 3 times 3, so it's x plus 3 times x minus 3. But we have a problem. Notice it's not a difference of two squares, it is a sum. That is a plus sign right there. This is not correct because if we distribute x times x, you get x squared minus 3x plus 3x minus 9, but negative 3x plus 3x, okay, that's 0, that's gone. That gives you x squared minus 9. That is wrong. It's got to give you x squared plus 9. So then you're going to say, all right, what about x plus 3 times x plus 3? If we double distribute there, we would get x squared plus 3x plus 9. And the problem is your middle term is not 0. That adds up to 6x. That's also wrong. So what happens in this case? We call this prime. Prime means you cannot factor. We can't factor this. It is already factored. So just be careful. The patterns are great, but it only works for a difference of two squares, and we don't have that in this case. Even if you try it, x squared plus 0x plus 9, what multiplies to 9 and adds to 0? Nothing does. Because to multiply to 9, it has to be 3, 3, or negative 3, negative 3. But that doesn't add up to 0. Okay, so you can't do it. And the last one here in this section, number 26, well, this is a problem. 50 is not a perfect square. It's 5 times 10, but that's not the same number. So actually, you'll be tempted to say this is also prime. But before we do that, notice that both of these are divisible by 2. I'm going to factor out a 2. And when I divide that out, we get 25x squared minus 4y squared. Look at that. That's perfect. That's 5x times 5x. 4y squared, the square root of that is 2y. That one does factor. So that's 5x plus 2y times 5x minus 2y. But don't forget that we originally pulled out the 2. That is still there. When you get your answer, and if you were to multiply it out, you'd have to go back to the original problem. You'd have to get the same thing. When you factor, you're not changing the value of this, you're only changing the way it looks. And that's really important. And that is the end of part 4.